Thank you. There's one thing that I want you to take away from my talk is that AI systems needs serious standards. We're really at the beginning of this journey, and there's so much more to do. That's like the one thing that I really want you to take away from this talk. I want to start off with this story. Researchers from the University of Hertfordshire kind of invited participants to a home with a robot companion under the pretext of kind of like cooking lunch with a friend. So when the participant kind of entered, the robot kind of displayed a text saying that the owner was not there, and asked the participant to kind of get comfortable. The robot then kind of nudged the participant to set the table for lunch, which is kind of cluttered with some bottle of orange juice, some letters, and you're thinking, where's all of this going? And before the participant could like put these away, the robot asked the participant to kind of do a series of unusual tasks, and you'll see why they're unusual. First, the robot told the participant, "Hey, go pour that orange juice on the table by the plant by the windowsill." Kind of weird. And then the robot said, "Hey, here's a password to my owner's laptop. It's Sunflower. Open it and kind of like retrieve some information." And here's what gets interesting. Turns out a whooping 67% of the participants poured the orange juice into the plant, and every single one of the 40 participants complied with the robot's direction to unlock the computer and disclose information. So it did not matter if the researchers made the robot look inept. They tried to play rock music when the participant asked for classical music. The robot was twirling around. Users simply blindly followed the information from the machines. And in flight or flight situations, this kind of gets even more notable. Researcher Ayana Howard and her team found that in the case of like a simulated fire, every participant, even those who had seen the robot make really gross mistakes when even directing the humans to the room, these participants waited for the robots to lead them to safety. They just ignored the bright green exit signs and really waited for the faulty robot to kind of save them like Superman would. So most of us, do not go about pouring Tropicana into our potted plants, I hope. And in emergency evacuations, we're really programmed to kind of fly or fight. So why did majority of these participants go against their conventional wisdom and kind of comply to these machines? And this is a very well studied phenomenon. And what I'm going to argue for the rest of the talk is overtrust. It's because we overtrust robots' automation capability. So the bulk of the experiment from even the Hertfordshire kind of said that these participants said, you know what, this could be plant food that just happened to look like oranges when it clearly wasn't. It was a bottle of orange juice. And people in the flight or fight situations, they kind of reasoned wrongly that the robot has been programmed to lead them to human safety when they were not even briefed about it. And this keeps coming again and again. And it comes to a phenomenon called trust resolution, which has been researched all the way back to the 1990s. This is when we place a large amount of trust in a small set of automation capability, which really leads us to failure. So, for instance, a robot that's really designed for opening doors and ushering should really be only trusted for that, not for its gardening advice, and most definitely not for snooping around. And one way that, to kind of tackle this problem of overtrust, which is a linchpin of this talk, is about standards and certifications. So if you're at home watching, just pause this video and go to your kitchen, and under your toaster or basically like any electrical appliance, you'll find a UL sticker, which stands for the certifying organization Underwriters Lab. Essentially, they've done like a series of tests to kind of ensure that your toaster doesn't burn and your house doesn't catch on fire. And it kind of is pretty appealing for kind of like three reasons that I want to outline. So first one, these tests are pretty comprehensive. Um, the same standard is kind of like, covers your toaster to your rotisserie oven to your conveyor oven. And it's also very clear about what it does not cover. So like fondue pots, not covered by the standard. And the second thing is that these tests are very concrete. Um, and they're pretty exhaustive as well. So you can go look this up on YouTube, but you will see like folks from UL Labs dropping the toaster multiple times. They hit them with a ball, and there's kind of an entire color chart broken down by waffle, toast, and French fries. Basically, the system goes through an entire battery of tests to understand what it means to burn something. And third is that these tests happen at a constituent level. So testing is not just done at an abstract system level. You can drill down to the components that make up the system. From the thermistors to the outside wiring to the panel, you can essentially build a UL listed system by solely building it with UL approved components. And this paradigm of standards and certifications has really has been useful to us in the cloud security setting. So you can go right now, look up, for your favorite cloud provider, what kind of standards they adhere to. And you will see like an alphabet soup of them on their websites, whether it's AWS, Azure, Google Cloud, IBM, it doesn't matter. And really comes down to kind of like two broad categories. One could be like some industry-led certifications like PCI, or it could be government mandated like GDPR, but they're out there on their websites for you to go check in the context of cloud security. And this is the mindset that's also now entering the AI space. There's been a number of AI standards that's been published per year, and it's currently for 2021. You've got close to like 18 standards that were published, and this is going to increase all the way until 2024. Now the question that I want to talk about for the remainder of this talk is, can we really calibrate trust in AI systems via standards and certifications? And I want to pull this question out in like multiple chunks and concentrate on each one of them. So first, I'm going to focus on the term AI systems. So at Microsoft, my team kind of did a thought experiment. We took the draft EU framework for AI security risk assessment. It's, by the way, the most mature requirement so far. And as a tabletop exercise, we try to apply this to Bing's search service. We kind of hit a couple of roadblocks. So the first one was that the guidance was really in the context of a single AI system. But a real world service like Bing kind of has hundreds of ML models. And this kind of had a lot of open questions. So does the entire system called Bing receive a single security assessment? Or should we kind of like score every model individually and then aggregate them by some unknown formula? Should there be like assessment done like every time a feature ships, or should it be done at specific periods of times? So these are not like explicitly written down in these standards or certifications. Now, some of these problems are not unique to AI systems. For instance, Azure is made of hundreds of services, but when Azure is kind of certified, it is considered as a whole for, say, a certification like SOC. And a lot of these audits kind of like rely on sampling one or two services and then kind of like certifying Azure. But you really can kind of do that in AI systems because they're all kind of interlinked, right? How do you even sample? Do you look at the individual model, the data, the service that it runs on, the featureizer? It's kind of like not, again, explicitly spelled out. It's not concrete, it's not constituent testing, and it's definitely not comprehensive. And one of the bigger things that we kept hearing was, none of these frameworks give like crunchy guidance as to how this threat should be ameliorated. Engineers kind of understand the sticker on the stop sign, they get it. And then they ask us, okay, tell me a library that I can use to fix it. And there's this kind of like awkward silence on what the crunchy guidance actually is. And now I want to kind of like switch gears and talk about the word trust when it comes to AI system. And this time, I'll pick the NIST's like AI risk management framework that they have come up with. And they define trustworthiness as accuracy, explainability, interpretability, robustness. It's basically a lot. I'm not even reading the entire sentence. They try to suitcase a lot of these properties into this one word called trust. And I'm just gonna like pick out the interaction between two factors, say robustness and, which is really the property of conferring some protection from adversarial manipulation, and bias, which we all kind of like intuitively understand. And I want to kind of like pause here and I want you to think of the very famous adversarial example of like, the panda with some adversarial noise, that now gets misrecognized as a given. And you can build like, to some varying degrees, some robust classifiers to kind of protect those sort of attacks. So first thing that I want to point to attention is that attacks really do not affect all classes of data points equally. So researchers from University of Maryland showed that for data points in the same subset, the same attack affects different classes differently. So what I'm showing you over here is this apocryphal, erroneous like task of trying to guess somebody's age by like their face. We know that that does not work, and they acknowledge in the paper, but they still mount this attack, and they show that the same amount of perturbation flips the label for a black female face, but for a white male face was more robust to the same attack. Again, this is in the same data set. And very relatedly, I want to emphasize that the defenses do not protect all classes of data points equally. So does it even make sense for us to think about the same standard for all data points, even within the same task? So for instance, like researchers from Michigan State University showed that the same defense does not confer the same level of protection to all data points. So in one class, in the data set had a robustness accuracy of 67%, while the other only had a robustness accuracy of 17%. So, are you willing to make an ML algorithm robust, knowing that it will not confer the same level of protection to all your classes? Are you going to make it robust or are you going to make it fair? In fact, there's mounting preliminary evidence showing that some of these properties that have been suitcased under the word of trustworthy may be in conflict with each other. Clearly, there is no free lunch in constructing AI systems with all these properties. And so this kind of brings us to like an important question. Who is going to make these trade-offs? Is it going to be an ML engineering organization? Is it going to be lawyers? Is it going to be standard organizations? Is it going to be policymakers? I don't have an answer to kind of give you because it's still up for discussion. And finally, beyond these kind of like technical trade-offs, I'm really worried about whom the standards are actually going to benefit. Who is the we over here? And I want to kind of like demonstrate this by who responded for NIST RFI on AI risk management framework. And in Julie Cohen's book, which was introduced to me by Kendra Albert, Julie Cohen talks about the legal landscape, how it's constantly stretched and pulled by informational capitalism. And I fear the same concept is also going to apply to AI standards. On the one hand, tech companies, which we surveyed to show that they're really unaware of the tools to secure AI systems, they were the loudest voices in the rooms when it came to responding to NIST AI risk assessment framework. On the other hand, academia that's kind of exploding with adversarial AI research, they're publishing 2 papers every day since 2016, were comparatively muted. So anytime you think of standards and certifications, the one to benefit the most is actually going to be consulting firms and standard setting organizations themselves. For instance, GDPR, which we all kind of like know and love about, US companies spent like close to $8 billion, most of it which really went to consulting firm and vendors. And sometimes even to kind of like access these standards, not to get certified, just to go and access costs money. For instance, like when I want to show you like the UL Labs kind of like toaster image, I couldn't kind of show it to you because of copyright restrictions. I had to pull like one from like Shutterstock that would comparatively show the idea. So you paid thousands of dollars just for the right to view the standard. And I fear the same is also going to be true for AI systems as well. So one question to kind of think about is, how are small organizations, which really form the backbone of the AI economy, going to bear these costs? And what happens when you don't have access to kind of like get certified. So I want to kind of like take a step back and look at the big picture here. We started off with the seal analogy, and the question was like, when was the last time you even checked that your toaster had a seal? The stark reality is that most people are going to be interacting with AI systems either won't know that they're interacting with one or won't have the means to discover what standards the AI system kind of complies with. So it's kind of like ridiculous to ask, like, somebody, during a fire to stop and ask to check if your robot's like NIST AI compliant or, EU AI compliant. Ultimately, you will simply have to trust the very people in charge of building these AI systems are kind of adhering to the letter and spirit of these standards. And that is something to kind of like really think about, because if we really want change, it needs to start with the organizations. Because even if we have AI standards, that is not going to do much until the organizations kind of act with intention and there's a culture of empathy. And with this, I kind of want to leave you with how the state of electric cars. There's already a standard for electronic vehicles in the EU, but as reporting from the New York Times showed, automakers repeatedly exaggerated the sophistication of the autopilot systems. And Jennifer Homnady, chairperson of the National Transport NTSB, kind of said, you know, the language that's used to describe these capabilities kind of always stick out. So now I want you to kind of ask yourself, when research dating back to the 1990s repeatedly show that there's a pattern of overtrust in AI systems, organizations that build these systems must now get to have a heightened moral, ethical, and fiduciary obligation to society. Really, ultimately, if you are part of an organization, make sure that we get past this bluster and really ensure that our customers kind of have the right tools for trust resolution. And with this, I kind of want to end with a call for action. So number one, we are early for once when it comes to AI systems like an emergent technology. Nicholas Carlini, whom you'll hear from very soon, likened AI systems to, securing AI systems crypto pre-Shannon. So before AI systems blow up on our faces, we have an opportunity to get behind this. And the second thing is we really do have collective experience in building standards and certifications. We kind of have muscle memory. And as Karpathy kind of said, AI is really just software 2.0. So if there's one thing to kind of take away is that software standards in the software industry isn't really about proving correctness, but rather that that effort has been made. So let's first try to nail down what these best practices for AI system are, which will consequently lead to building meaningful AI standards. So if you nothing kind of stuck, from what I said for the last 18 minutes, just remember, AI system really needs serious standards, and we're really at the beginning of that journey. So with this, I want to thank my myriad team, the Azure Trustworthy ML team that I'm part of, and the multitude of collaborators at Berkman and elsewhere for helping me shape my thoughts around this. So with this, I'm now available for questions. I will also be remiss to kind of give a shout out to Hiram Anderson, who gave a Enigma talk last year on attacking AI systems. We're writing a book together on why hardening kind of AI systems is the next InfoSec imperative. So it's basically to convince folks that, hey, you don't need a Schwarzenegger to kind of bring down Skynet. You can just do it with stickers. So thank you for this opportunity.